All right, homework 11 is exponential and logarithmic regression, and then choosing the best model for different types. So we have 4 on the front. We're doing 2 with exponential, 2 with logarithmic. The process is the exact same. I'm going to make sure that you have both equations on this front page. So an exponential model is this. You have y equals a times b to the x. And remember, when you type this into Desmos, or we'll recap how to do it on the graphing calculator as well, you would make sure that you have like the x1 on Desmos, or that you'd have those values typed into the different columns when you do it on your graphing calculator. All right, so we have y equals a times bx. That's the exponential model. The logarithmic model, just so you have it, is a plus b times the natural log of x. But other than knowing the equation for Desmos, the process is the exact same. If you use a graphing calculator, you don't have to have those equations memorized because the calculator kind of takes care of it for you. So with number 1, let me show you what it looks like on Desmos first. So you've got a table to set up, so you just add this table. We're going to type in our data. So remember, with years like this, you just do 8, 9, 10, 11, 12, rather than actually typing in the 2000. So 8, 9, and then it starts to guess where we're headed. So then type in our y1, so 27, 500, 24, 200, and always be super careful when you're typing these things in. Double, triple check them, make sure the values are right. Okay, so you've got that typed in. So we have our table right here. Again, double check all the values, make sure they're correct. And then in your second box, you're going to type in the regression. And you start with y1, and then instead of an equal sign, you go to functions. In the middle is stats, and you have that little squiggly equal sign. And then we type this in, except in place of an x, we have x1. So a times b raised to the x1 power. And as soon as you do that, it's got your regression right there for you. So you can see we've got those values to sub in, and those values are going to create your equation for you. All right, so we've got A is 76, so we have y equals 76,466.1, that's A, and then times B, which is 0.88 raised to the x power. Okay, so that's always the first part, is just actually creating the equation, and then estimate the value of the car in 2016. So 2016 would just be plugging in a 16 for x. Okay, and then that can get typed into Desmos, that can get plugged into the calculator, you know, wherever it is that you want to plug that in. Since I'm using Desmos here, might as well show you that you can just do calculations. Okay, so you do that, and then that gives you that value. Again, it's money, so make sure that you are using just 2 decimal places. So $9,889.90. Okay, so that would work the exact same way for the logarithmic, the other exponential ones. Let me show you really quickly on our graphing calculator. Okay, so you want lists and spreadsheets, and you're going to type everything in the way it is over here. So 8, 9, 10, 11, 12, and then you do the same thing in this column. Okay, so if you're watching these videos, just whatever method you're using, just feel free to skip over the other one. All right, so we press the menu key and go down to statistics. Stat calculations is the first option, and then you've got all of these in here. So we are doing exponential regression, so you can either scroll all the way down or you can just press the letter A. And so it's going to ask you where your lists are. X is A1, change Y to B, and then press enter a couple times, and it will put everything in here for you. You can see you've got the value of A right here. You've got the value of B right there, and you just have the exact same stuff that you have right there. So 2 different ways to do it. Let's look at our second page. We'll take a look at number 5. This one you're comparing different models. So this one you're using the regression coefficient. So you've got your r squared. I'm going to show you guys where that comes from. So let's open up something brand new right here. Type in this table. So So we have 0 through 4. Or just for comparison's sake, on the calculator. Actually, I just did how to do it on the graphing calculator, so you guys can compare those if you're using one. All right, so you've got that all typed up. So those are all your data. So we're going to check linear, quadratic, and cubic. So you have 3 different things to type in. So you type them in the exact same. Y1, you still use this little squiggly. Linear is just an mx plus b. And remember, instead of x, you just always use an x1. So m, and then x1 plus b. So you've got that. So if we see here the r squared, that's a terrible regression. Like normally you want them to be like 0.97, 0.98, something like that. So we're going to assume that's probably not it. Move on to the next one. So we have y1, little squiggly, and then we're going to do the quadratic. So this is ax squared plus bx plus c. So ax1 squared plus bx1 plus c. We'll check this model. So that's a really good start, the 0.9902 for the regression correlation. Let's check the cubic as well. So this one we have y1, little squiggly, and this time we start with the cubic and work our way down. So this would be x1 to the 3rd, arrow out of the exponent, plus, and then bx1 squared plus c x1, and then finish it off with plus d. So this is 0.9947. So both high, both great approximations. You can see the 0.9947 compared to the 0.9902 is just a little bit bigger. So we're going to write down that we've chosen the cubic. So which model is going to be the cubic? And then we are going to write down all of this information right here. So you have a function f of x equals a is 1 point, let's go with just 2 decimals, so 1.17 x cubed minus 20.79 x squared plus 52.48 x plus 249.43 is your constant. So question says, estimate the height of the rock at 5 seconds. So we can do f of 5, and then that would just get subbed into the calculator everywhere that there's an x. Okay, and you can do that in Desmos, you can do that in a graphing calculator, whatever method you are currently using. Just want to make sure I'm showing you guys a variety. Okay, and so we get about 138.33, and that would be in feet.